inside of another function.
Mm-hmm.
Then this is the rule. So you have like one equation, basically kx, and there is f, and inside fx also there is one gx.
Yeah.
For example, you have 2x. Let's see, how can I write this one? I will use from here. So, just a moment, I have to figure out this app.
No problem. Take your time.
Yeah, thank you. Oh, come on, man. Yeah. Okay, yeah. So for example, okay. So you have y is function to x,
Mm-hmm.
and then on the power is sorry, 5x squared plus 2.
Yeah.
Yeah, you see, so in this case, if you use the general rule of the derivatives that we learned last week, it is not possible to calculate, because you have one function which
Uh-huh.
is 2x, right? And then on the power of this function, you have another function which is 5x squared plus 2.
Yes.
Yeah. So, for example, we can also write this one as u to the power v. Or sorry, let's use the same one what was being used in the CCVX1. There they write fx. So, oh, so you have like fx to the power gx. Yeah, we can call whatever uv or fx gx its way.
Uh-huh.
CVX is using this one, so I will call the same one. Or let me in parallel also do it in u to the power v, because then we can see it very easily. Yeah. So in this case, fx is 2x and gx is 5x squared 2.
Yeah.
And then first, then we will find fx is equal to 2x and f bar x is equal to. Now you can determine the derivative of fx, right? What do you think it is?
Derivative of fx.
Yes.
So you got one up there. You get it in front of it. It's just two.
Yes, right. And then gx is 5x squared plus 2. Then
Excuse me. One question. If you
yes,
if you take that power, like in two x, it's in that case it's to the power one. Do you place that one in front of the two, or do you place it in front of the x?
it doesn't matter because they are multiplying. So basically, if you multiply 1 times 2 or 2 times 1 is the same. So it doesn't matter.
Okay, yeah.
Yeah, it's either way is okay.
Okay.
And again, we have like 2, 5. 5 times 2 is 10. And
And the
then,
yeah.
yeah,
Okay.
okay. So the chain rule says, if you look in the equation
Uh-huh.
from Vx, this is f bar gx times g bar x. See?
So the derivative of gx.
Yeah, so we will use
So
this one.
that's equal to 10, yeah.
Yeah, and then
Times
f bar of gx, it says this one.
it
Yeah,
says
in this case, yeah, in this case there is no x basically, so it
yeah,
is 2. Yeah,
that's 2 times 10x,
you are right.
and then you get 20x.
20x. Yeah,
And that's the answer to this question.
yes. So that is how
Okay.
you solve it. Yeah, and
Not difficult at all.
no, it is easy, and I will show you again how you remember the chain rule, or what, where does it come from. Like, okay. So in the previous example, we have like, so basically, let's get back to the old style of function. Y is fx, like, and then what we have to find dy over dx.
So the derivative of uh,
Yeah,
fx.
yes. But like fx is also a function of different function. Fx is equal to, for example, let's say ux.
Yeah, that could be
Good.
true. I don't
Yeah,
know. Yeah.
yeah. So this is like a composite function, you see. So it's same like what you have composite function. You have a
In
function.
this case, you use the chain.
Yes. So you have this function inside of f, inside of the
Uh-huh.
f. So this is a whole function, and ux is part of this function. So you have, this is very similar to the previous one. And then basically what you are doing is we have to find dy by dx. So what we are doing is just splitting it, dy over du times du over dx. You see, when you actually eventually you can cross this one,
Uh-huh.
and
It
then what is left
becomes
is dy over dx.
yeah.
So this is what we are. This is the chain rule, basically the rule, the basic rule of the chain rule. If you get confused with the formula, then what is happening is,
Could you give me an example so I can try to solve it?
you mean from like a
The,
tutorial? You mean?
for the
Yeah.
chain rule.
Okay.
Just
Yeah.
just one example so I can try it.
Okay. Yeah, that's a good idea. Just a moment. So let me clean this, or I can go to next page. Yeah. Okay. So okay, find dy over dx.
The answer is e to the power 5. It's like that. Like it is
Uh,
written already.
Sorry. So this is the question. So y is given by this equation.
Yeah, and the answer is the formula you just gave, I think.
Yeah.
Yeah, the answer is e to the power 5x to the power 2 plus 2x plus 3. That's the answer.
You think this is the answer?
It was something like that, right? If it's e to the power something, it stays e to the power
Yeah.
something.
Yeah, you were right. So the basic rule for derivative says you have like dy and then e to the power x, then it remains e to the power x.
Then I remembered it right.
Yeah. But in this case, you have to use chain rule because in the numerator, it's not only x, but you have a function, this function.
Oh, so
Yeah.
I do have to. Okay.
Yeah. You do have to use the chain rule. Or otherwise, I will say you to make it very easy, we can. So do you want to do it together or you want to do it by yourself first?
Um, I I'd like to try it. Um,
Okay.
so my fx is just e, right?
Yeah.
My fx, my derivative of fx is just e
Yes.
of
So what
fx.
you have is e fx. Your fx is e to the power gx.
Yeah,
Yeah.
gx. So my gx.
Oh, sorry. Messed it up.
Do I write uh, g and then like that small thing in the top and then x for the derivative of gx?
Sorry, what do you mean?
Like, do I write g accent x for the derivative of gx?
Yeah, yeah, you're right.
Okay.
Yes.
So g accent x is equal to 5x to the power 2. That becomes 10x plus 2x is 12x. So my derivative of gx is 12x.
Mm-hmm. Isn't it? So what I get is 10x plus 2.
Yeah, 10x plus 2x.
No, you have to do. Okay, I will show you. So we have fx is equal to e to the power uh, gx, right?
Yeah,
And gx is 5x squared plus 2x.
yeah,
Then g bar x is 5 times 2 is 10,
I
and then
got
x,
that.
and then x 2 minus 1 is
Oh,
x,
wait, of course,
right?
there's a 1 on top of that.
Yes,
I
you're right.
forgot that.
And
So
then,
there's a 1 on top, is just 2. So
yeah, okay, yes, that's good.
that's what I forgot. So 2.
Yeah.
And after that, I take what do I exactly take? What was the formula like?
So basically, you already know it, but even so, let's write it. F bar x
F bar x
is the same, right? So you know it already. So
is E, yes.
yeah, z to the power x. So fx is also what is fx is equal to f bar x as well. So
Yeah,
now we know the chain rule, right? I will the derivative says y bar. Oh shit, y bar is given by f bar gx, right?
F bar GX. That's what I was looking for.
Yeah. Times
X
g bar x.
G bar.
Yeah. So now replace the items. Let's plug it in these items.
So Y bar is equal to F bar GX is equal to that, so 10x plus 2.
Uh, yes. First, which are you replacing? First, the first term you have like two terms here. You see, so you have one and then two. Which one are you following? The first one, this one, or
Oh, I took the 10x plus 2.
okay, okay, yeah, that's okay. You can plug it in any order. It's okay.
And then the e to the power g.
Yes, e to the power
Or
gx, but we don't want gx, but let's write what is the original gx. What is the original gx?
the original gx is 5x to the power 2 plus 2x plus 3.
Yes.
Plus 2x.
Yeah. So that's the answer.
And this is the answer. I don't need to solve anything after this.
Mm, that's it. So
Okay,
yeah,
I got it. Okay,
okay.
got it.
Let's do more examples of this type.
Yeah, great.
Yeah. Oh shit. So y is e to the power sine x.
So y is e to the power sine x. So again, I need a fx, which is e,
Yeah.
or f bar x is e to the.
Yeah. So first thing, what? So let's make a procedure.
Uh-huh.
Our first step is to find fx,
Not
and
f
then
bar x. It's just fx.
yeah. And
Okay.
let's first find out what is fx in this case, in the question itself.
E,
E to the power gx, right?
gx, yeah.
Yeah. And then what is gx?
Gx is sinus x.
Yes, sinus x.
G
Right.
f
So on the basis of that one, we can find
sinus.
f bar, basically, yeah, f bar x, and then g bar
So
x.
f bar x stays the same,
Yes, you are right. E to the power gx. So these are the basic rules. Yeah.
and then gx,
Mm-hmm.
g bar x, excuse me, is equal to what rule is there for sinus?
Maybe in for Viskunde A is not so important, or maybe if it is, then they will give it because then for sinus, this is a general rule. For sinus, it's always cosinus x.
Okay, so cosinus x.
Yeah.
Next step is the f bar of gx. Bar is f bar of gx,
Yeah. So next, let's write down the equation what they gave in the. So let's down the chain rule equation.
the general equation I just wrote down, which is y bar is f bar of gx times g bar x,
Yes, you're right. So and now what we all need to do is just replace those terms. So
which is f bar gx is
mm, this one.
e to the power g. Oh, is that isn't that gx? Oh yeah, yeah.
Yeah, you are right. So, but we don't want to write gx,
We
but we have
want
to
f
write
bar
what?
x, which is e to the power gx
Yeah, and gx is
sinus
actually
x,
yeah. So we will write
sinus
oh
x
sine x
times
times
cosinus x.
yes, that's it. Okay, okay. Let's do one more, the last one. Then I think then you know it pretty much.
Mm-hmm.
Sine.
As a little child, I was always looking at these type of calculations, and I was thinking like only the smartest of the smartest people will answer these questions.
No, but now I think you know it how easy they are, right?
Yeah.
Yeah.
So y is sinus five to the 5x to the power 2 minus 3x plus 2.
Mm-hmm.
So we need an fx, which is what? Sinus only
Yeah, you're right. Sine of they say gx, right? Yeah.
is sine of gx. And then we need a gx, and that is 5x to the power 2 minus 3x plus 2.
Yes, right.
5x to the power 2 minus 3x plus 2. Then we need the derivative of it. The
Yes,
derivative of sinus gx is cosinus gx.
very good. Yeah.
F bar x is cosinus gx. And then the g bar x is equal to 10x minus 3, and that's it.
Yes, good.
10x
Now our general equation is
f bar. Oh, wait, something fell off my desk. Um, the general equation is y bar is f bar gx
mm-hmm.
times g bar x. And now we fill that in. Y bar is equal to cosinus and the no cosinus and the original gx. So 5x to the power 2 minus 3x plus 2. Cosinus 5x to the power 2 minus 3x plus 2 times the gx, which is 10x minus 3.
You're right. So yeah, as you can see in my screen, so please take care of the brackets because like if you don't include this bracket, then it could be confusing that it is maybe cos sinus x and then this complete thing.
Uh-huh.
But this is one term and this is one term.
I'll
So
just always use brackets for the f and the g. For
yeah, yeah,
both formulas, I'll use brackets. That wouldn't make any difference then.
yeah. Okay, yeah.
Okay, I got this.
Okay. Now we are done with the chain rule. So let's next try the CCVX problem. Okay, getting back to this one. Mm, oh yeah, yeah. So this comes from CCVX, you see.
Yeah.
Uh, so I copied both English and Dutch terms. Yeah. Oh, so this is where you have to use some derivative. So this is the problem 2 from one of the example questions. So let's solve this together. And by the way,
Um,
is it possible for you to open this question somewhere else? Like,
of course, I can open it. Which exam was it? The first exam?
yeah, first one, yeah.
Let me have a look. So, CCVX. The first. Is it in Dutch or in English? English, okay.
Yeah, whatever you feel, what is easier for you.
I'm
Yeah.
okay with both, but my test is in
Okay.
Dutch.
Yeah.
I don't care. Um, question 2, you said, right?
Yeah.
The maximum return of an investment.
Yes, that's it. So, okay.
Yeah.
So let's try to solve it together then, like we did for the general problems.
Uh-huh. So
Uh,
pastry chef Peter has developed a recipe for banana pie. Since he does not have money of his own, he's looking for an investor to finance the production of these banana pies. In order to convince the investor, he asks his friend, accountant Anton, to draw up a model that will predict the possible profit of the investor. Anton presents the following model. The fixed cost for producing the banana pies is 250 euros. The variable cost per produced pie is 2 euros. If the selling price is set by the formula PQ is 14 minus 0.05Q, with PQ in euros and Q the number of produced pies, all produced pies will be sold. Peter indeed uses the formula to determine the selling price, and he wants to know how many pies he must produce to maximize his profit. Anton explains the profit in euros is given by the formula PRQ is
Okay, yeah.
equals to minus 0.05 q to the power 2 plus 12q minus 250. Use the relation profit is revenue minus total cost to verify the formula given above is correction. That the formula given above is correct.
Yeah. Okay. Let's solve the first one first, and then we can proceed to the next one. So for the problem A,
So
uh,
12 to A
so we need to derive this equation what they already gave. We have to find it back using the relation profit is revenue minus total cost.
So let me have a look first. I don't really understand the question, that's why. Use the relation profit to verify that the formula given is above is correct. Okay, and that's to determine the selling price, and, and that's for the maximum profit. Okay,
Yeah. So we can start with this with the oh shit. They have already given profit is revenue
minus total cost.
total cost, right? Yeah. So what is revenue is so how can we find the revenue? Revenue is so what I think you know revenue, right? So
Yeah, of
I,
course. I'm doing a business study.
you are you are the business guy, so I think you know it. So selling price per stock, right? Times
The
total
amount.
total pies.
Yeah,
Yeah, right. Okay, yeah, or amount, like you said. Okay.
yeah.
So what is the selling price?
The selling price, he uses 14 minus 0.05 as the formula for that.
Yeah.
So revenue is the
Yes.
selling price being 14 minus 0.05 Q
Mm-hmm.
times the amount of pies being
Yeah.
Q.
Yeah. So I think you already can see on the question, they say they already give Q is the number of produced pie. So Q is the variable in this case, right?
Yes.
So,
So now I have to fill in
oh,
this, or
yeah, you have to work out the brackets.
yeah, which is
Right.
14Q minus 0.05 Q to the power X. To the power 2, excuse me.
Okay, yeah, that's right. So okay, we have found this
So,
item. So what we need is the next one.
the total cost. The total
Yes.
cost being total cost is um, the fixed cost is 250 and the variable cost per produced. So 250 plus 2 Q.
Uh, 2Q you said, right? Yeah.
Yeah.
Yeah. I think you know it, so I'm not explaining anymore. So okay.
Q.
So now next thing is we know the profit, we just fill in on the profit one. So
So profit is the formula for the revenue, which is 14Q minus 0.05Q to the power 2. And then minus,
yeah,
I'll place both in brackets, minus 250 plus 2Q.
yeah.
And
Yeah, it was very good of you to put this one inside the bracket, so not to mistake with the minus one. Yeah.
And basically, there is a 2q on the right side and there is a 14q on the left side.
Yeah.
Uh, we have to subtract these of each other, so that becomes 12q.
Right. Yes.
And then we're left with the all the others. So it becomes the formula which is given there. PRQ PRQ is minus 0.05 to the power q to the power 2 plus 12q minus 250.
Yeah. Okay. So now we verified that the formula given above is correct. So right.
Yeah.
Yeah.
B.
Okay. That was not so difficult, I think. So we can move.
No, it was just trying to imagine everything.
Mm. Yeah, I think the most important thing is to understand the question, I think, and
Yeah,
how are they all related to profit, revenue, total cost. Yeah.
I had quite a difficulty with that in my past, so
Mm.
I
Okay.
tried to do my
Yeah.
best.
Okay. I will give you one tip. Maybe the first important thing is to know what is your variable.
Uh-huh.
Maybe we should have started with the first question we should have asked is what is the variable in this case? So
Uh-huh.
Q. And what
Yeah.
is the meaning of Q is the number of pi. So I think that is the most important thing to
Important.
start
Yeah.
every problem. Yeah.
Use the derivative function to determine the number of produced pies at which the profit is maximal.
Yeah.
Which the profit is maximal. So for a
Mhm.
maximum profit,
Yeah.
we
So
use the
for example,
star
okay.
Q is. I'm just applying the whole thing, right? So the PR bar Q is equal to 2 times 0.05 is what? 2.0.025
Mm-hmm.
Q plus 12, and that's it.
Yeah, you are right. So let's say this is so if you can see my screen. So let's imagine this is on the x-axis you have the sorry Q. Oh, so the equation of profit versus Q is given like this, and I don't know the exact curve, but we can imagine it is something like this.
Uh-huh.
They want us to find the maximum profit for which the Q. So they have to find this point. So at this point, the profit is maximum, you see.
Uh-huh.
So we have to find the value of Q at this point. So what is this Q? We have to find this one.
Okay, but I did the derivative. I have the derivative in front of me right now.
Okay, that's your okay. We are here. Yeah. So
Am I done with that or no? Because I have to give a Q, right?
yeah, you have to do, so what is your derivative you found? Let's
0.025 Q plus 12. Yeah, minus 0.0. Sorry, yeah.
yeah, Q plus 12. You're right. Yeah. So you have to find what you need is this value, this Q. So for
Uh-huh.
what value of number of pies produced. So what is the next step you think? So this is the first step, which is good, and then we have to find actually the value of Q.
For the maximized profit.
Yeah.
Am I supposed to use the whole profit is revenue minus total cost again?
No, not really. So you this is the derivative, you see?
Yes.
What you are finding is the slope at every point.
Uh-huh.
You know? So at this point, what is the slope at the maximum profit, you think? So at this curve, at the maximum point.
I have no clue to be honest.
Okay, no problem. We can see. So in this function, it's increasing, increasing, and until there is a peak, and then after that peak is decreasing,
Yeah.
right? So this is the
There is
maximum
right
point.
there.
So the slope is increasing, and at this point, this will be
So at
0.
some point it will go down again.
Yeah, yeah, and that is at the maximum point, this will be 0. So for that one, I will share my screen from the computer again. Oh, yeah.
Can we have like a procedure for this too?
Okay, just a moment. Yeah. Okay. Oh, so can you see my screen now? Yeah.
Yes.
So when you have a curve like this, you
Uh-huh.
have a positive slope and then you have a negative slope. And at the top, at the peak, the slope is 0 because it's straight, you see?
Yeah.
Yeah. So also in this case, in the example, we have at the maximum profit. So this is the maximum profit point.
Yes.
At this point, the slope is 0.
Mm-hmm.
Yeah. So this is actually know how you have to know that, okay, at the maximum, the slope is 0.
So for that you fill in 0 for the derivative of q.
Yes.
So you fill in 0 is equal to minus 0.025x q plus 12. And then you just take the 12 to the other side, becomes minus 12. Yeah, minus
Sorry,
12.
sorry. Oh yeah. You're right. Yeah.
Minus
Thank
12 is minus 0.025q. And then then you divide, right?
Yeah, then divide both sides by minus 0.025.
And then you get the answer. I got minus my calculator right here. Let me just calculate it. 12 divided by, or wait, minus 12 divided by minus 0.025 is equal to 480.
Yeah, so that number of pies. Yeah,
Okay, so that's the maximum. Now I get
yeah,
that.
yeah,
Just fill in 0 for the derivative. Understood.
yeah. So then the let's say the main key point is that you have to know that this is 0
Yeah.
at the maximum. Yeah.
Okay, understood.
Yep. Okay. So then we can go to the next point. To the investor, not only the profit but also the return of his investment is of importance. Exactly. Yeah. This is given by another formula. This one. The return in percentage for the investor in Peter's banana pies as a function of the number of produced pies Q is thus given by this equation.
Uh-huh.
Okay, we
Compute
have a
algebraically
equation.
the number of produced pies at which the return of investments is maximal for the investor.
Mm,
For this, so I first need a derivative for that, right?
yeah, or let's
Is
before
this
that, let's imagine a function again.
this is the quotient rule,
Yeah, yeah,
and I don't remember that
yeah.
shit. Uh, I'll need to read this one more time. Excuse me. To the investor, not only the profit but also the return on investment is important. It's important that it's given by the formula now. The return in percentage for the investor in Peter's bananas and banana pies as a function of the number of produced pies. Q is thus given by. Okay. So the two functions are just the same, but then in numbers.
Sorry, what do you mean? Then
So
they
the
are the
whole
same.
return on investment is equal to profit divided by investment times 100 is the same as RQ
Ah,
is.
yeah, you're right. Yeah. So
Okay.
basically, that is the basic, the return of investment. The first equation is the basic formula, and then they replaced the above formulas, and then this is the output. So
Am I
this is
missing a question? Because it says I'm here at 2D, but we haven't done a C.
yeah, you're right. To me also, it's the same one.
They
Oh,
can't do
check
anything right.
that. Maybe the Dutch version has a different one.
They can't do anything right.
Ah, yeah. No, the Dutch version actually says it's A, B, C, so it's only numbering the numbering error.
Ah.
No.
Okay. So first of all, I need the derivative of it.
Mm.
Therefore, I can use my formula list. There is a formula list. So
Yes.
let me
Yes.
grab that first.
Yeah.
I'll try this on my own first.
Okay. Yeah. Good.
CCVX,
Mhm.
math, syllabus. So the formula list gives me Qx is Fx divided by Gx, and the derivative of it is Q bar x is F bar x times Gx minus Fx times G bar x divided by Gx to the power 2. So I'll write that down for a second.
Okay.
Qx is Fx divided by Gx, and the derivative of it is Q bar x is F bar x times Gx minus Fx times G bar x, and then divided by Gx to the power 2.
Yes.
So if I fill in this, wait, where is it? It becomes R bar x, or wait, let me just rewrite this too. RQ is minus 5q to the power 2
Mm-hmm.
plus 1200q minus 25,000 divided by 250 plus 2q.
Yes. Right.
So in this case, the upper part is fx and the
Yeah.
down part is gx. So
Yeah. Okay. Yeah.
r bar q is equal to fx being uh, minus 10.
Yeah. Let's first individually write fx and gx. So what
Okay,
is
yeah,
fx?
of course.
Yeah.
F bar x is 10x plus 12,000, and that's it,
Yeah.
plus 12,000. And then g bar x
That's
is equal to 2.
right. Yes. That's it.
So r bar q is
Yeah.
equal to
Shit.
f bar x, so 10x plus 12,000
Mm-hmm.
times gx, the normal gx, so 250 plus 2q, 250 plus 2q. Um, the minus normal x, which is minus 5q to the power 2, minus 5q to the power 2 plus 12,000 minus 25,000 times the gx, which is 2, times 2.
Gx and
G
g
bar
bar
x,
x different,
G
right?
bar x, of
G bar.
course. And this divided by gx to the power 2, which is 250 plus 2q to the power 2. Okay. Um, I'll need to write this on another piece of paper because my piece of paper is full
Yeah.
now.
Yeah. It's a very long equation. I can
This is
understand.
why
Yeah.
I hate the quotient rule.
Mm.
Um, So basically, I can first get rid of the power on the down part, right?
Yeah, let's do that.
That
Uh,
becomes
my paper as well. This is getting very long.
okay. Okay,
Yes.
I want to write this down in a way so that I don't have to write everything again.
Um,
There's 12,000. I can get rid of the 12,000s, the 10x. Okay, you know what? I'll just get rid of the upper part first.
okay.
That
Yeah.
becomes 10x times 250, which is 2,500 x.
Sorry,
2000.
can you repeat that again? I'm not following you actually. I cannot see what you are writing there.
I multiplied the 10x by the 250.
Okay, yeah. By the way, at this moment, X is Q, right? You understand that one. So if
Yeah,
yeah,
of course. Yeah,
it would be used Q. Yeah. Yeah, right. Yeah. Okay.
I wrote down x here. I don't know why. Q.
Yeah, okay. Whatever. The question is okay.
2500 q, and
Mm-hmm.
then 20q to the power 2. Wait, I got a problem. I did something wrong here. Gx is plus, right? Yes. Thank you.
Yeah.
I wrote down multiplied by. Uh, so 20q plus 20q to the power 2,
Yeah.
and then um, I place this in between brackets. Is
Not
that needed?
really. No, in this case, it's not needed. So
No.
you multiplied minus 10Q with the thing in the second bracket. So next thing you do is
Now I have to do the
multiply to the power.
12,000 times 250 and then times 2q. So 12,000 times 250 is 3 million.
Sure.
So plus 3 million.
Sorry, can you recheck if that is 1200 or 12,000? Because I have 1200.
Is it 1200?
Yeah.
Oh,
So
I
it's
made a mistake
1200,
here.
I think, not 12,000. I think
Yeah,
you
I made a mistake here. Yeah.
confused. Yeah.
Just 1200, nothing more, right?
1200 times 250, right? You did that one.
And then we get 300,000, so 1 0 less.
Yeah.
And then 2400 Q plus 2400 Q.
Yeah.
And then
Mm. Uh-huh.
minus, and then what is it? Minus 10 Q to the power 2.
So do you want to, are you putting the brackets on or you don't have the brackets? That
I have no
depends.
brackets now.
Yeah. Okay, then you have to careful. There is minus times minus, then it
Where?
becomes plus.
Where?
So so in front of the minus 5q squared,
Yeah, there's a minus. Oh, of course.
yeah. So
I
you are
see.
multiplying minus times minus 5q squared times 2. See, there are three elements.
So that becomes plus.
Yes. Or if it is very confusing, what you can do is
Just
let
put
it
on the
be like
bracket.
this. Yeah, and keep the brackets.
Yeah,
So
I'll just
it's
keep.
up to
So
you. So you choose, yeah.
before the minus, I put everything in between brackets, and the after it, I'll put everything in between brackets,
Yeah.
which gives me minus 10q to the power 2
Right.
plus 2400. Is this then?
Yes.
2400 minus 50,000.
Isn't that 5,000?
Is that did I put a zero there too much too? No, it's
Uh,
25,000 in the formula.
oh yeah, you're right. That's sorry, I made a mistake. That's 25,000. So it should be 50,000. Yeah. Yes.
Um,
By the way, did you include a Q on the on your second expression?
uh,
2400 Q.
is it 2400 Q?
Yeah. So this is so if
So
you
in the
go
first one, I need for the 3 million also a Q.
no, not on that,
300,000.
not on this one.
And what? Oh wait, because this is a G bar X. Okay, yeah, I got it. Of F bar X, excuse me.
Yeah, this is no, that is not the F bar X. This is FX.
Yeah,
F
yeah.
as it is. Yeah.
Okay, yeah, I understand it. I just get
Yeah.
confused of all the
Okay. Yeah.
bars and.
Mm.
So now I get rid of everything, right?
So or or you can do at the same time also the thing on the denominator. You can expand it.
I can do that too.
Or
So
let's do it like this. Let's keep it like this for now because the denominator we can do in the end also.
yeah, because this is a bit too long for me.
Yeah.
Uh,
Yeah. Okay. Let's finish the one on the above one. Yeah.
so
So
first
we
of all,
open the brackets.
the left part we can add the 2500 Q and the 2400 Q, right?
Yes.
That becomes 4900 Q. 4900 Q.
So can you check it again because you have I think
2500 Q plus 20 Q to the power 2 plus 300,000 plus 2400 Q.
aha, I think you made a mistake in the previous one then because it should be minus 2500 Q minus 20 Q squared.
What? Why is it minus?
Because because the derivative, like the what was it? The term f bar x. Yeah. F bar x. What is your f bar x?
My F bar X is 10x plus 1200.
Ah, you forgot minus, I guess then. It should be minus 10x plus
Oh, of
1200.
course, because it's minus 5Q to the power 2.
Yeah,
So that makes that this is minus.
yeah. So now you can rewrite. So it's minus minus then.
So minus 24, 500
Yeah.
and minus 2400.
Uh, no, minus 2500 Q minus 20Q squared
That's where it is. Okay.
plus 300,000 plus
So
2400 Q.
so
So
okay.
first two should be
That's
negative.
that. So if we get rid of all the brackets, we get minus 100Q
Yes,
minus 20Q to the power 2
yes,
minus 20Q to the power 2 plus 300,000.
right.
And on the other side, we can't do anything.
So now you open the brackets on that one also.
By doing minus times minus 10 to the power 10Q to the power 2,
Yes.
that becomes
Mhm.
plus 10Q to the power 2. And
Mm,
then minus, is it then minus 2400Q?
you're right. Yeah.
Minus 2400Q. And then plus 50,000.
Yes.
So now we get rid of everything. It becomes minus 2500Q
Yeah. Minus 25. 100.
minus 10q to the power 2
You are right.
plus 350,000.
Correct.
And now we got the down part.
Yeah. Okay. I would say leave that down. What is in the down denominator? Leave it as it is.
Just as 250, or wait, did we have? We had something else.
That's the square squared of the gx.
So that's
Gx.
62,500 plus 2 q to the power 2.
Mm-hmm. You already opened the thing on the denominator, did you?
Yeah.
Okay. I would say it's not necessary because you will see in a while. Yeah. Okay. So we are up until this point. So we have the derivative r bar q.
Yeah, R bar
Right?
Q.
Yeah. So what we can do next is so we have to find the maximum again, like similar to the previous problem.
So fill in 0.
Yes. So this whole thing is equal to 0.
Okay.
Yeah. Okay. So and you know you can cross multiply in this case, right? You know it. So
What
0.
do you mean with cross multiply?
Okay. So I will show you my screen again. Do you
Yes.
see my screen? Yeah.
Yeah.
Yeah. Okay. Plus 35, 350,000 divided by we have this thing squared. So cross multiply is basically, I think there are different ways to say it, but this is you can do this term like this
Uh-huh.
multiply.
So
So
0
basically,
divided by the whole formula.
yeah. So 0 is 0 divided by 1 actually. So
Uh-huh.
this is whatever here is not so important because we are multiplying this by 0, so we don't
Uh-huh.
need to work it out, you know. So
That's why you said you can leave
yeah,
it. Okay.
yes. So this is
Oh,
basically same but without the denominator.
uh-huh. So it's equal to only the top part.
Yes. So now we are getting to the much simpler one, yeah. And what I can see, maybe can you see how can you simplify this one more further, this equation?
Get 350,000 on the other side.
I would say
The
you have
root
like
of
you have
10.
you have 0 everywhere, you see? Here you have 0, here you have 0,
Oh,
you have
yeah, of course, yeah. You
you
can
can
get,
divide by 10 on both sides.
yeah,
Yeah.
that's
So
just to simplify it for yourself.
yeah.
Um, but I have to get the root of 10q to the power 2, right?
Yes, that is the main idea, yeah.
And I can place the 350,000 on the other side.
Yeah, so let's rewrite it.
By the way, you missed 1 0.
300, is it 300, is it?
350,000. You got 35,000 in the last one. Oh
Uh,
wait, you wait,
oh,
you divided it by 10. I forgot, sorry.
yeah, 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 that's right, yeah.
Is
Yeah,
minus 200.
maybe the mistake was here, not here, but here, I think.
If I'm doing like the root of, am I supposed to do it of the whole formula or only over the q to the power 2?
Sorry, what do you mean by that? You have to
Uh,
do
when I have to take the root, right?
okay, so let's look at this. You can rewrite this one as so we make the q as a positive. So the first thing we made is move this one. So
Of
let's move
course.
thing to the other side.
I took the 350,000 and placed it on the other side.
You have to put everything because this is a
Uh-huh.
quadratic equation. Yeah, is equal to 0, right?
Yes. Oh wait, just the ABC formula?
Yes. And
Oh,
then
b minus b plus minus what was it? Minus b plus minus two. Wait, minus b plus minus. It's given in the formula list too.
Yeah, it is. It is in the CCVX formula. Yeah.
It's a shame that I forgot this. Minus b plus minus the root of b squared minus 4ac divided by 2a. That's a shame that I
Yeah.
forgot
Okay. Yeah.
that.
Maybe it's been a long time. So yeah. Okay.
So 10 minus 10q to the power 2. Yeah, you divided it by 2. I didn't yet. But
Okay. Divided by 10, right? Yeah. Is
q
50.
5 350,000. So B is 2,500 for me. For you, it's 250.
Oh yeah, yeah. You can do either way. You will get the same answer. Yeah.
X
Correct.
is minus B, so it becomes plus 2,400 Q
Mhm.
plus minus the root of
So let's
B
say
to the power 2, so that becomes minus to the power 2 is minus 6,250,000.
Okay. B squared is 25. 62500.
For you, it's 1 0 less, I guess, or 2. I
Yeah.
don't know.
2. Yeah.
2,
So
yeah. Minus 4ac, so 4 times minus 10 is 4d, and then times 350,000. 40 times 350,000 is for me 14 million, for you two less zeros, I guess.
yeah.
14 million. And this divided by 2a, which is 20, minus 20.
Mm-hmm.
One question: when I have to divide this, all of this, am I supposed to get the 2,500 plus minus in there too?
When you divide everything, you mean?
Yeah. Am I supposed to divide everything by 2, or only the everything under the root?
No, everything. Basically everything. Yeah. So it's covering the whole of the numerator. Yeah.
Okay. So for me, minus 6,250 2 3 minus 14 1 2 3 1 2 3 is equal to minus 20,250,000, and that the root of this is math error. Okay, that's not good. So minus
Oh.
20,250, 20,250,000. The root of this is the root of minus 20,250,000. I I got math error. You get that too, or
Sorry, how much did you get?
um, I I first subtracted everything under the root, and then it gives
Yeah.
me math error when I take the root of it.
Okay. So can you look at my screen? Maybe we are using a different equation, but maybe very
Yeah, it's the
similar.
same equation, only with less twos.
Yeah. What is your C in this equation?
350,000. Yours is 30. What? 3,500.
Not exactly. Mine is minus
35,000. Excuse
35,000.
me.
Minus 35,000. Yeah.
Yeah.
So
Oh,
maybe
mine is
you
plus.
you forgot the minus maybe.
Oh, mine is plus. Why is mine plus then?
We have to, can you send me the picture on WhatsApp? Then
Oh,
I
of
will.
course. When you place everything on the left side.
Yeah.
Oh, okay. Yeah, I get.
So you see squared. So the general equation is everything is plus, but in your equation, I think you have plus, plus, minus.
I have plus plus.
So A is plus, B is plus,
Oh,
C
no, A
should.
is minus.
Oh, okay, A is minus, B is
Plus,
no. Is it then you did something wrong because it
I I
should
know
be
what
either plus, plus,
I know.
minus, or it should be minus, minus, plus.
So where is yours? Minus 250 minus 10Q plus 350,000. Okay, yeah, I see yours there. Right.
Yeah, and then you. So I
Okay,
would suggest
could
you.
you please go back once more?
Yeah, yeah,
Um, plus minus. Yeah, I see
yeah.
what I did wrong.
Yeah, or the other one is this should
My
be minus, and then this should be plus. So,
my mistake was that when you put the zero on the right side, I forgot that everything turns the other way around.
yeah, you are multiplying by minus one. Yeah,
Yeah.
yeah.
So I got a problem right here. And my problem is that could you go one page to the right?
Okay. Then you have like you define what is A, B, C, and then replace it.
Yeah, so it becomes
For me, that is
so
four.
this is not a minus at all, and this is a plus. This is a plus, right? 4AC becomes plus, right? Minus
Or
4AC.
yeah, yeah, it should be plus. Yes. Otherwise, then you get a math error because you have the negative inside the
Yeah,
root. Then it's error.
but in
Yeah.
the formula it says minus B squared minus 4AC, right?
You mean the formula? Uh,
The formula says minus 4AC,
yes.
but how is this plus then? 4 times 10 is 40 minus.
Then your A is negative. So either your A is negative or C is negative. You
My
see?
C is
So,
negative.
yeah. C is negative. So that means you are multiplying minus 4 by negative C. Then it becomes plus.
Wait.
So
Yeah, I got 14 million, yeah.
yeah, okay.
But, huh? I didn't get it. Something is wrong with mine. How,
Uh,
if the formula says B squared minus 4AC, how does it turn plus? It
okay. So
literally says minus 4AC.
yeah, let's do it. So B squared minus 4AC, right?
Yeah,
So so in your case, B is minus 1, I suppose.
it's 10, just 10.
Yeah. Oh, yeah. Sorry. Yeah. Why is it 10? Then it shouldn't be 10 then. Or let's see. Okay, let's write everything. What is your B?
My B is 2500Q plus, and my C is minus 350,000.
Then your equation is not right then. So then you made a mistake over here on this part.
Yeah, I know that there's something wrong with mine
Yeah.
because up until there we got the same thing. Up until the zero is equal to 250q minus q to the power 2 plus 335,000. Until there we got the same.
So this is
My problem is in the part that you just circled with purple.
So this is okay. This part is okay for you.
Yeah, yeah, that's okay. I got
Yeah.
that too. But the
Okay.
second I have to put the zero on the left side and all the other things on the left side and the zero on the right side, excuse me.
Yeah.
At that
So in
moment,
this,
it was wrong.
so you have this one is minus, this one is minus, and this one is plus, right? On your one as well, and
Yeah,
extra zero.
minus minus plus.
Yep.
So if I place the 2500Q on the left side, it becomes plus, right?
Yeah. Then it becomes plus. Yeah.
If
That.
I put the minus 10 q to the power 2 on the left side, it becomes plus, right?
Ah, you are right. Yeah, you are right. Yeah, it becomes plus. Yes.
And then if I do plus 350,000 on the left side, it becomes minus.
Yeah.
And that's
So
what I have.
yeah. So you have like plus. So what is A? A is
10.
plus 10. Yeah, and
For
B
you,
is
just q. My b is 2500 q. For you,
yes.
is that's 2500.
Yeah,
And
only
then minus
2500. Yeah, and
350,000.
C is
Minus 350,000.
yes, right.
So something is off with mine.
So what you said is A is, you see here. So this A should be plus 10 then.
Yeah.
Yeah. So 4 times
10.
A, A is plus, yeah, plus 10 times
But it's
this,
minus 4. It's not just 4.
yeah, minus 4. So here you have 1 minus, and here you have minus. Then this becomes plus. Minus times minus is plus. You see?
Let me just write it with you. Minus 350,000. It becomes 14 million.
Maybe I'm missing 1 0 right here.
Yeah, no, for you it's two zeros less. That's
Mhm.
I don't know, 1,400,000, something like that. I don't know. Oh no, that's mine.
Yeah, no, the last one I'm doing is yours. So on the bottom
Okay.
is the same
So
equation.
if the number is a plus number, I have to add it up.
Yeah. Basically, in an equation, you have so if either A or C should be negative.
Either A or C should be negative,
Yeah.
and that's the case with mine.
Yeah. So your C is negative, right?
Yeah.
So that means this whole thing becomes plus because you are multiplying minus with a minus.
Okay, so this becomes plus. That's 20,250,000. The root of 20,250,000 is equal to 4,500. So x1 is equal to 2,500 plus, what is it, 4,500
Yeah.
divided by my,
Mhm.
in this case not minus but plus 20
Yep.
is equal to, um, let me have a look. This 7,000 divided by 20 is 350, of course. So x1 is equal to 350. X2 is equal to
Mm.
uh, 2,000 divided by 20.
I'm not following you actually, honestly. But again getting different answer, unfortunately.
No, no, we are getting the same, I guess. Let me have a look. Uh, 2,000 divided by 20 is equal to x2 is. So my x1 is 350, or yours is minus.
Yeah.
Why is yours minus then? It's minus 750.
So your B was so it should be minus B, eh? So in the equation. So in the
Oh yes,
quadratic equation, it
it's
should be
minus B,
minus
of
B.
course. Yeah,
Maybe.
I forgot to adjust that. Becomes
So it
minus.
should be so your B is 2500, right? Your
2,000. Yeah, yeah.
yeah. So that means it should be minus 2500 in the beginning.
Uh-huh. So minus 2,500 plus 4,500.
Yep.
But how did you get 200? Oh yeah, that's 200, and that's two.
Yeah. So one
The
time
other,
you use plus and
yes,
the one time you use minus. Yeah.
I got I got the things the other way around. So here it becomes minus.
So you have like 4,500, right? So if you take plus,
Oh, I got everything right now. I see what I did wrong. So 2,000, 7,000 divided by 20 is minus
oh yeah,
50,000.
yeah,
Yeah, I got it the other way around. Okay, I got this. So this whole thing
yeah,
is one answer.
yeah. So you have to know that you have one plus and the one minus. You see,
Yeah.
but and what we are trying is so if you go back to the question,
Oh
the
yeah, we
question
had a
is
question, right?
the number of produced pies. That is the question, right?
Number of at which return on investments is maximal. What? What did you say?
Yeah. So this is the number of pies, and
Yeah.
the number of pies cannot never be negative. So this answer you have to
Yeah.
ignore. So this is invalid. This is not valid answer. So this is not possible. So the only answer is 100. So your answer in this case is 100.
Yeah. Got it.
Mm. So this one you have to ignore this one. Yeah.
After writing one and a half paper full.
Yeah, this is a very long equation and too much of algebra. Yeah.
Okay, I got it.
Yeah.
Oh,
Then
got
you have the 6 points finally. Yeah. Okay, that was it for today. So
yeah. Thank you very
yeah.
much.
So how confident are you with the derivatives now? Do you want to
Quite,
move to the next chapter, or do you want to continue with
I'm
still
quite
more problems?
full with it. We got only the product and the sum right left.
Oh yeah, yeah, yeah,
The
yeah.
product
We
was
will sum rule and the product rule. Yeah, we will do that in the next one. That should be very quick. Yeah.
yeah, I see it. It's not that difficult. No, it's not that difficult.
Sum rule basically we did. You just didn't notice maybe because I will show you the sum rule basically.
And we did use the product rule, but it was like implemented in the quotient rule.
Uh,
It is almost identical. Like it says for the product rule, it says f bar x times gx plus fx times g bar x, and the upper part of
yeah,
the
yeah,
quotient rule says f bar x times gx minus fx times g bar x. It's almost the same.
yeah, yeah. You are right. So basically, if you can do the quotient rule, you can do basically everything because
Yeah.
everything is incorporated on this one. And if you look at my screen, so
Yes.
for example, in this case, maybe you think this is like should you use chain rule or the product or the additional rule, sum rule?
Yeah. So
What do you?
I think we use the sum rule. So y bar is equal to 10x
Yeah. So this is fx plus
plus
g. So this is in this form. If
cosine,
it was like this, then you should use chain rule. But this is just this one.
and the answer is 10x plus cosinus x.
Yes, right. And then if you have
Oh, is
this
it
kind of situation,
multiplied by?
now this is a new problem.
Oh, that's a new one. Okay, yeah.
And then what kind of rule do you think you should
In
use on
that
this
case,
one?
it's the product rule,
Yes,
which
that's it,
is
basic. Yeah,
f bar x times gx plus g bar x times fx.
yeah, right. And then here you have new problem. You see this one?
Which is f bar x times gx minus g bar x times fx divided by gx to the power 2.
Yeah, right. So there you use the derivative rule.
Okay,
Sorry, the rule. Okay, the last one.
is the chain rule.
Yeah, I think you know it already. Then yeah. So sine 5x squared.
That is so the f bar gx times gx,
Yeah, so the fx is sine x, sine
which
gx.
becomes cosinus
Yeah.
x,
So that's cosinus, the thing on the bracket,
and then
multiplied
we're
by
left
tan
with the
x.
g bar x, which is 10x.
Yeah.
So sinus x times 10x.
Yes, that's it. So I think we don't need to spend more time on the sum rule
No,
and the product.
I'm
You know
quite
it.
sure we don't.
Yeah, that's it.
Okay, thank you very much. Could you send me a ticket for this class again?
Okay, I will do that. And by the way, I asked you to send me a review on the apprentice. Is it
Yeah,
still
I tried that. I got an email for it, but I couldn't reply on it on the email. I couldn't click on the link.
Aha. I don't know what we should do then.
I'll try
So
to
it
go
is not.
to the
Can you try once again?
website itself.
Or can you try once again, or maybe you could go directly to the website. I'm not
Yeah,
sure.
that's what I'll try to do. I'll
That
go
would be
directly.
very useful for me, like to get
Yeah,
more students. Thank you.
of course.
Okay, I will do that, and let's make a plan for the next one because we have to
Um,
see.
Let me have a look in my agenda.
Mm,
Um, I am free on Tuesday again.
Okay. By the way, I have exams coming on the end of May, so I would like to do until end of May. I would like to do until only one per week. Is it
Yeah,
okay for
no
you?
problem. No
Yeah.
problem.
And then after that one, if you want, we can do two or even three times. Then I have more time then.
Yeah, okay, no problem. I got till July to
Yeah,
do this.
I think it's okay. And what is the next thing we should do? Do you think my idea is to do go to probability and
Yeah,
combination and permutations maybe next one?
yeah, I would love that.
Uh,
And
probability.
huh? And then we'll discuss what we'll do next. So for the next class, we got probability.
Yeah.
Okay.
So next Sunday, right?
Yeah. At 6 again?
Yeah, or even this time is also fine for me. What do you prefer?
I I prefer the in the morning, 11 in the morning.
Okay, let's do it at 11 in the morning then. Up
Okay, great.
11 till 12. Yeah.
11 in the morning on Sunday the 17th.
Yeah, 17:05. Yeah.
So, math, 11:00. Okay, got it. Thank you very much, and I'll wait for the ticket to come.
Okay, thank you and see you next week. Yeah, take
See you
care.
next week. Bye.